When wiring a 220-volt compressor motor with 4 wires, understanding the wiring diagram is crucial. The motor you described has 4 wires labeled PON, T5, T4, and TO. PON is an ungrounded wire used for clockwise rotation. T5 and T4 are for the line voltage connection, and TON should be capped. When connecting this motor to a 10-gauge wire with black, white, and green conductors, follow these steps. Firstly, PON, the ungrounded wire, should not be connected to the motor frame as a ground. Secondly, T5 should be connected to the black wire, which is the hot wire. Thirdly, T4 should be connected to the white wire, which is the neutral wire. Fourthly, TON should be capped and insulated using electrical tape. It is very important to ground the motor frame using a separate ground wire, either green or bare copper. This ensures electrical safety. Before making any connections, verify that the voltage and amperage rating of the power source matches the motor's specifications, which are 220 volts and 16 amps in your case. Always use appropriate connectors and crimping tools to ensure secure and reliable connections. If you're unsure about any step, it's always best to refer to the manufacturer's instructions or consult with a qualified electrician for specific wiring requirements. Prioritize safety by disconnecting power before making any wiring connections. Wear appropriate safety gear such as gloves and safety glasses. Before energizing the motor, double-check all connections to ensure they are correct and secure. To elaborate further, let's break down each wire connection in more detail, focusing on why each connection is essential for the proper and safe operation of the compressor motor. The PON wire, designated as ungrounded for clockwise rotation, plays a role in the motor's internal circuitry for determining the direction of rotation. Grounding this wire to the motor frame would create a short circuit, potentially damaging the motor and creating a safety hazard. Instead, this wire is part of the motor's internal winding configuration to achieve the desired rotation. The T5 and T4 wires are your line voltage connections, providing the necessary electrical power to run the motor. In a 220-volt circuit, you have 2 hot wires, but in this context, we are treating one as hot, which is the black wire, and one as neutral, which is the white wire, for clarity. The black wire connected to T5 provides one leg of the 220-volt supply, while the white wire connected to T4 provides the other leg. This configuration allows the motor to receive the proper voltage to operate. It is very important to ensure that these connections are secure to prevent voltage drop and potential overheating. The TON wire being capped and insulated is also important. This wire is not used in the current configuration and needs to be properly insulated to prevent it from coming into contact with any other conductive surfaces. This could cause a short circuit or electrical shock hazard. Electrical tape or wire connector can be used to safely insulate the end of the TON wire. Grounding the motor frame is a critical safety measure. The green or bare copper wire provides a path for fault current to flow back to the electrical panel in the event of a short circuit within the motor. This low impedance path allows the circuit breaker to trip quickly, disconnecting the power supply and preventing electrical shock or fire hazards. The ground wire should be securely connected to the motor frame using a proper grounding screw or lug. When working with electrical wiring, using the correct tools and materials is very important. For example, when connecting the 10-gauge wire to the motor wires, use appropriately sized wire connectors that are rated for the voltage and amperage of the circuit. Crimp the connectors using a crimping tool to ensure secure mechanical and electrical connection. Using the wrong size connectors or failing to crimp them properly can lead to loose connections, overheating, and potential electrical failures. Remember, before starting any electrical work, always disconnect the power supply at the circuit breaker. This prevents accidental electrical shock. Double check that the power is off using a voltage tester before touching any wires. Wearing safety glasses protects your eyes from debris or accidental sparks. Gloves provide insulation and protect your hands from electrical shock. Working in a well-lit area and keeping your workspace organized also contributes to a safer work environment. When checking your connections before energizing the motor, carefully inspect each wire connection to ensure that it is secure and properly insulated. Look for any loose wires, exposed conductors, or damaged insulation. If you find any issues, correct them before proceeding. Use a multimeter to verify that the voltage at the motor terminals is correct and that there are no unexpected voltage drops. Ensure the ground connection is secure and properly connected to the grounding system. By following these steps, you can safely and effectively wire your 220-volt compressor motor. Always prioritize safety and consult with a qualified electrician if you have any doubts or concerns about the wiring process. Remember, electricity can be dangerous, and it's always better to be safe than sorry. In addition to the steps already outlined, consider these additional points for a comprehensive understanding of wiring a 220-volt compressor motor. Firstly, understanding motor rotation is key. The pone wire, when left ungrounded, facilitates clockwise rotation. If counterclockwise rotation is required, the manufacturer's instructions should be consulted, as it might involve swapping specific internal connections, a task best left to qualified professionals. Secondly, wire gauge selection is very important. Using 10-gauge wire is appropriate for a 16-amp motor on a 220-volt circuit for relatively short runs. However, for longer distances, a thicker gauge wire might be necessary to minimize voltage drop. Voltage drop occurs when the voltage at the motor terminals is significantly lower than the supply voltage at the breaker panel due to the wire's resistance. Excessive voltage drop can cause the motor to run inefficiently, overheat, and potentially fail prematurely. Consult an electrician or use a voltage drop calculator to determine the appropriate wire gauge for the specific length of the wire run. Thirdly, overload protection is critical. While the circuit breaker in your electrical panel provides overcurrent protection, it's also good to consider adding a motor starter with the overload protection. A motor starter is a device that provides a controlled start to the motor, reducing the inrush current that occurs when the motor is first energized. The overload protection component of the starter monitors the motor's current draw and trips the starter if the current exceeds a preset level for an extended period of time, protecting the motor from overheating due to overload conditions. Fourthly, conduit and wire protection is also important. Depending on the installation location, you may need to run the wires in a conduit to protect them from physical damage. Conduit is a metal or plastic tubing that encases the wires, providing a barrier against impact, moisture, and other environmental factors. Use appropriate fittings and connectors to properly secure the conduit to the motor junction box and the electrical panel. Fifthly, understanding the motor's nameplate is useful. The motor's nameplate contains valuable information about the motor's specifications, including the voltage, amperage, horsepower, RPM, and other important data. Refer to the nameplate to ensure that you are using the correct wiring configuration and that the motor is suitable for your application. Sixthly, double-checking torque specifications is useful. When tightening the wire connectors and grounding screws, use a torque wrench to ensure that they are tightened to the manufacturer's specified torque. Over-tightening can damage the connectors, while under-tightening can lead to loose connections. Seventhly, testing and troubleshooting is an important procedure. After wiring the motor, test it to ensure that it is running properly. Use an amp meter to measure the motor's current draw and compare it to the nameplate rating. If the current draw is significantly higher than the nameplate rating, there may be an issue with the motor or the connected load. If the motor does not stop or runs erratically, troubleshoot the wiring and connections to identify and correct any problems. Eighthly, regular maintenance is important. Regularly inspect the motor and wiring for any signs of damage or wear. Check the wire connections for looseness and tighten them as needed. Keep the motor clean and free from dirt and debris. Lubricate the motor bearings according to the manufacturer's recommendations. Finally, seeking professional help is also worth considering. If you are not comfortable working with electricity, or if you have any doubts about the wiring process, consult a qualified electrician. A licensed electrician has the knowledge, skills, and experience to safely and effectively wire your motor and ensure that it meets all applicable codes and regulations. Hiring an electrician may cost more initially, but it can save you time, money, and potential safety hazards in the long run. Wiring a 220-volt compressor motor involves understanding the specific wire functions, following proper connection procedures, and prioritizing safety throughout the process. Remember to disconnect power, use appropriate tools, and double-check all connections before energizing the motor. By following these guidelines and seeking professional help when needed, you can ensure a safe and reliable installation. To further clarify the process, let's delve deeper into some of the potential issues one might encounter and how to address them. Firstly, dealing with unusual wire colors is important. While standard electrical wiring uses black for hot, white for neutral, and green or bare copper for ground, older installations or non-standard wiring may use different color codes. If you encounter wires with unusual colors, use a multimeter to identify the hot, neutral, and ground conductors. Alternatively, consult with an electrician to determine the correct wiring configuration. Secondly, identifying capacitor-style motors is also key. Some compressor motors use a capacitor to provide extra starting torque. These motors will have a capacitor wired into the starting circuit. When wiring a capacitor-style motor, carefully follow the wiring diagram to ensure that the capacitor is connected correctly. Incorrect capacitor wiring can damage the motor or prevent it from starting. Thirdly, understanding dual voltage motors is useful. Some motors are designed to operate at multiple voltages, such as 120 volts and 240 volts. These motors will have multiple sets of windings and a wiring diagram that shows how to connect the windings for each voltage. Ensure that you are connecting the motor for the correct voltage based on your power supply. Fourthly, dealing with junction box limitations is important. The motor's junction box is the enclosure where the wire connections are made. If the junction box is too small or crowded, it can be difficult to make secure and reliable connections. Consider replacing the junction box with a larger one if necessary. Also, be sure to use appropriately sized wire connectors that are designed for use in junction boxes. Fifthly, addressing motor vibration is useful. Compressor motors can vibrate during operation. Excessive vibration can damage the motor and connected equipment. Mount the motor on a stable surface and use vibration dampening pads or mounts to reduce vibration. Sixthly, managing thermal overload is important. Motors can overheat if they are overloaded or if they are not properly ventilated. Ensure that the motor is adequately ventilated and that it is not being overloaded. Consider installing a thermal overload relay to protect the motor from overheating. Seventhly, dealing with power quality issues is useful. Power quality issues such as voltage sags, voltage swells, and harmonics can affect motor performance and lifespan. If you suspect power quality issues, consult with an electrician to analyze the power quality and implement solutions such as surge suppressors or harmonic filters. Eighthly, understanding local electrical codes is crucial. Electrical codes vary depending on your location. Ensure that you are familiar with the local electrical codes and regulations before wiring your motor. These codes specify the requirements for wiring, grounding, and safety. Ninthly, keeping detailed records is important. Keep detailed records of the wiring configuration, the date of installation, and any maintenance performed in the motor. This information can be helpful for troubleshooting and future maintenance. Finally, seeking ongoing training is useful. Electrical technology is constantly evolving. Attend training courses and seminars to stay up to date on the latest electrical codes, best practices, and safety procedures. By understanding these potential issues and how to address them, you can ensure a safe, reliable, and long-lasting installation. Remember, safety is always the top priority. If you are not comfortable working with electricity, consult a qualified electrician. Let's explore some additional considerations for wiring your 220-volt compressor motor, focusing on best practices and preventative measures. Firstly, proper wire stripping techniques are important. When stripping insulation from wires, use a wire stripper tool that is specifically designed for the wire gauge you are working with. Avoid using a knife or other sharp object, as this can damage the conductor and weaken the wire. Strip only enough insulation to make a secure connection and avoid nicking the conductor. Secondly, creating secure wire splices is essential. When splicing wires together, use a wire connector that is appropriate for the wire gauge and the application. Twist the wires together tightly before inserting them into the connector. Ensure that the connector is properly tightened to provide a secure and reliable connection. Avoid using electrical tape alone to splice wires, as this can become loose over time. Thirdly, labeling wires is useful for future maintenance. Use a label maker or permanent marker to label each wire with its function. This will make it easier to identify the wires in the future and can save time and effort when troubleshooting or performing maintenance. Fourthly, documenting the wiring configuration is valuable. Create a wiring diagram that shows the connections between the motor wires, the power supply wires, and any other components in the circuit. Keep this diagram in a safe place where it can be easily accessed in the future. Fifthly, using strain relief is important for preventing wire damage. Use strain relief connectors to prevent the wires from being pulled or strained. Strain relief connectors are typically installed at the point where the wires enter the junction box or other enclosure. Sixthly, providing proper overcurrent protection is critical for safety. Ensure that the circuit breaker or fuses in your electrical panel are sized correctly for the motor's amperage rating. Oversized overcurrent protection can allow excessive current to flow through the motor in the event of a fault, which can damage the motor and create a fire hazard. Undersized overcurrent protection can cause the breaker or fuses to trip frequently, which can be a nuisance and can also damage the motor. Seventhly, performing regular inspections and maintenance is vital. Regularly inspect the motor and wiring for any signs of damage or wear. Check the wire connections for looseness and tighten them as needed. Clean the motor to remove any dirt or debris. Lubricate the motor bearings according to the manufacturer's recommendations. Eighthly, verifying proper grounding is extremely important for safety. Use a multimeter to verify that the motor frame is properly grounded. The resistance between the motor frame and the grounding electrode should be very low, typically less than 1 ohm. If the resistance is high, there may be a problem with the grounding connection. Ninthly, understanding motor starting methods can be useful. Different motors use different starting methods, such as across-the-line starting, reduced voltage starting, and soft starting. The starting method can affect the motor's inrush current, which is the current that flows when the motor is first energized. Ensure that the starting method is appropriate for the motor and the power supply. Finally, staying informed about industry best practices is a continuous process. Attend electrical trade shows, read industry publications, and participate in online forums to stay informed about the latest industry best practices. This will help you to improve your skills and knowledge and to ensure that you are using the safest and most effective methods for wiring and maintaining electrical equipment. By following these best practices and preventative measures, you can ensure that your 220-volt compressor motor is wired safely, reliably, and efficiently. Remember, safety is always the top priority, and it is always better to consult with a qualified electrician if you have any doubts or concerns.